So the first problem of higher order differential equation is this. We have A. Show that y is equal to negative cosine hx is a particular solution of the equation y double prime plus y prime minus 2y is equal to e to the negative x. And B. We have to determine A so that y is equal to a sine hx would be a particular solution of this equation. So in finding the general equation of a non-homogeneous linear equation, must first solve its associated homogeneous equation. So we have yc m squared plus m minus 2 is equal to 0, m plus 2, m minus 1 is equal to 0. We have m1 is equal to negative 2, m2 is equal to 1. So we have the complementary function y is equals to c1 e to the negative 2x plus c2 e to the x. So we have now the associated homogeneous equation. Step 2 is we must find its particular solution. So in finding the particular solution, we must have an educated guess. It is motivated by the kinds of functions that make up the input function g of x. So our g of x in this equation is the e to the negative x. So as we can see, g of e to the negative x is an exponential function. So it is reasonable that our yp is in the form of a yp is equal to a e to the negative x, wherein our a is the specific coefficient. So we have yp is equal to a to the negative x, yp prime is equal to negative a e negative x. This I'm finding the derivative. Then yp double prime is equal to a e negative x. So substituting this in the equation y double prime plus y prime minus 2y is equal to a negative x. So we have y prime double prime plus y p prime minus 2yp is equal to e negative x. So we have this. So substituting, so can conclude that a is equal to negative 1/2. Therefore, substituting our a is equal to negative 1/2 on yp, we have yp is equal to negative 1/2 e to the negative x. So back to our complementary function, which is yc is equal to c1 e to the negative 2x plus c2 e to the negative x. We can use this c2 e to the negative x to find another particular equation. So substituting the a is equal to negative 1/2, we have negative 1/2 e to the x, which is another particular solution. So combining that, first yp is equal to negative 1/2 e to the negative x and yp negative 1/2 e to the x. So we have a particular equation, this. So extracting the negative 1/2, we have this. Since we know that cosine hx is equal to 1/2 e to the x plus e to the negative x, so we can conclude that y particular solution is equal to the negative cosine hx. So back to our problem, we have proven that, as stated in the problem, that y is equal to negative cosine hx. So question B is that determine a so that y is equal to a sine hx will be a particular solution of this equation. Y double prime plus y prime minus 2y is equal to e to the negative x. Since our yp coming from the problem we solve in a, we have yp is equal to negative 1/2 ex plus e to the negative x. So a particular solution must be in this form. and given that the constant is negative 1/2, so we can use another constants for this particular solution. So we know that sine hx is equal to 1/2 e to the x plus e to the negative x, which was also 1/2 e to the x plus 1/2 e to the negative x. So from the particular solution, so their difference only is their constants. So for them to be the same, we have y is equal to a sine hx. So it can be concluded that a is equal to 1.